Let's hit the record button. Let's maximize and let's review. So I'm just going to skim through this. In math, we use variables to represent unknown quantities. A constant is a known quantity. It's a number that we know about. Algebraic expressions are mathematical statements that contain variable terms, constant terms, and math operations. Terms are separated by pluses and minuses. So 3x plus 7 has two terms. 3xy is only one term because remember, terms are separated by plus and minus signs. Okay? So then scroll down a little bit more. If you take an algebraic expression and you set it equivalent or equal to another algebraic expression, you have what we call an equation. Okay? Now, there are two big differences between an algebraic expression and an equation, and that is the directions. If you see the word simplify, there's no left and right hand side because there's no equation. It is just an expression, and that is it. So you're going to simplify. You're going to combine like terms. You're going to bring things together. An equation, the directions will always be solve. We want to know what does x equal. And that means eventually you have to move terms from the left side of the equation to the right side of the equation and so forth. All right. Now, we really didn't do too much of that. We're going to be doing that today. All right. So you're going to see that in action. Then we talked about just evaluating expressions. Evaluate means substitute in and simplify. If I say x equals a number, substitute it in and just tell me what it simplifies down into. Okay? Then let's see here. We talked about exponents. And we defined, and I'll put a little box around it. We defined what an exponent is. So a to the n, where a is the base, n is the exponent, means that we are going to take that base and multiply it n factors. So, for example, 2 to the third, and you're going to hear me ask you this a lot, is 2 to the third, you're going to hear me ask, what does it mean first? And then you would say 2 times 2 times 2. Then I would say, okay, great. What does that simplify to? And then you would say 8. All right? So let's see here. What else did we learn? We learned about that. Where's the good stuff? We learned about the order of operations. And this is where Stevie had one of the best quotes I've ever heard from a student, which is, when did all this change? And the answer was, it never changed. It's always been like this. All right? So I kind of view the order of operations at a little bit of a different lens than what we were taught. I like to stack them because when I look at stacked things, I think, okay, this is first, this is second. And since parentheses is first, we do that. Exponents is second, we do that second. And then, like I said, the way I envision this is multiplication and division is on this third line. So I'm going to write some numbers here. 1, 2, 3, and 4. So since multiplication division is on that third line, that means they're equal. However, we do them from left to right in the order in which they appear. And Stevie, I think that's where you made the comment, when did this change? And I agree with you. It kind of seemed like it changed, but in reality, it didn't. All right? It's just that oh, I'm sorry, Steve. You're going to say something.
No, I was just going to say, I was talking to some people I went to school with, and they said the same thing. I was like, do you realize that it's different now?
Yeah, unfortunately, it is not different. Now, what you can do, though, is the best thing that you can do, which is help your friends, which is a great thing. All right? I love helping people. So, multiplication division on the same line. Therefore, they're equal in terms of their priority. So you do them left to right in order. And then addition and subtraction is on the fourth line. They're equal in terms of priority. Therefore, you got to do them from left to right in the order in which they appear. And then to finish up the day, what we did is just a bunch of different examples. Okay? That's all we did is just a bunch of examples. So before we move on to the next section, which we're going to do today, I want to just give you a problem with the order of operations. And all I want you to do is just simplify it. Let's get math going here on an early Friday morning. A brisk early Friday morning. Notice I am wearing the hoodie. We are rapidly approaching my favorite time of the year, which is hoodies and shorts.
I love this weather.
Oh yeah, and I will wear this till about January. And then it starts to get a little too cold. That's when I got to put pants on. All right, so here we go. It's just a little warm-up exercise example. All right, try that. So as you're writing, I'll read it so you can hear it, so you can kind of understand it. This is read 7 to the second power minus 3 times the quantity of 2 squared times the quantity of 5 minus 2 squared. Oops, sorry, let me move this. I'm kind of blocking everyone's view now. Come on. There we go. Sorry about that. All right, did anybody get an answer yet?
I did. Are we supposed to get a negative?
No.
Oh my god.
I hope not. Let me do the math real quick.
I got 110, but I'm sure it's probably wrong.
110?
Yep.
Okay, I don't think that's right. So, Stevie, did you get negative 59?
Yeah.
Yeah, that's actually correct, but you shouldn't have got a negative because your professor didn't give you a good problem, everybody.
Okay, you confused me. I was like,
Yeah.
where did I go wrong?
Yeah, I gave you a bad problem, everybody. I gave you a bad problem because you shouldn't get negatives yet. So, can you all do me a favor real fast? Change the 7 out front to a 12. Sorry, I'm going to use the 21-year-old excuse. Yo, it's Friday, bruh. I hear a lot of people use that, bruh, when they talk, especially like when they get nervous or angry. And I'm like, I don't know what you're trying to tell me here. Keep saying bro. So sorry about that. It's Friday. I had a late night last night. Although tonight's going to be a good night. It's wrestling night and I get to order pizza. Okay, are we good? Did we fix it? All right, so let's go over this. So real quick, on the right-hand side, I like to write out my order of operations. So I'm going to need to start inside the parentheses. Now, the brackets, remember, they act as parentheses. They're just grouping symbols. That's all they do. But we need to focus on the innermost. So my first move is going to be right here. So I'm going to rewrite everything exactly the same. Except 5 minus 2 is 3. So now I still have parentheses. So I look inside, and the parentheses are those big brackets. So I need to do the work inside there. And I notice I have 2 to the second power times 3 to the second power. Now, we know exponents takes precedence over multiplication. So what I'm going to do is draw 2 little arrows and drop down my exponents. 2 to the second is 4. 3 to the second is 9. Last thing I'm going to do, inside the parentheses here, inside the brackets, I'm just going to multiply 4 times 9. Which is going to give me 36. So parentheses are done. Now I'm going to just tie up any loose ends with my exponents. That's going to be all the way out front. 12 to the second is 144. Minus 3 times 36. So now my exponents are done. Next, I'm going to multiply 3 and 36. Now, 3 times 36 is 108, am I correct? And that's where I made my mental math mistake. So now multiplication, division's done. So the last thing I need to do is just subtract. What's 144 minus 108?
34.
34. Good. We can call it a day. Any questions? All right. So let's move on to the next section then. All right. So this section, we're going to focus on
Isn't it 36?
Oh, is it? Did I make it?
Yeah.
Okay. Oh, hold on. Let me do this. All right, you got to borrow. Becomes a 3. That becomes a 10. Or a 4. What am I doing? 10. 14. 14 minus 8 is 6. Kim,
My bad.
you know what excuse to use. It's Friday, bruh. That's the excuse. All right. Who said that, by the way?
Stephanie.
Thank you, Stephanie. Now, in this section, we're going to focus on combining like terms. So let's review what terms are first. Remember, variable terms contain a variable. It looks something like this. Okay? But now we're going to break this down a little bit further. Because this 3 actually has a very special name. Now remember, this is read 3 times x. And that number 3 is called a coefficient. Okay? We also have constant terms. And that looks like this. It's only a number. All right? So we just say that the 4 is just a constant. Okay? So, I guess if we're with our friends, we call it a number. If you're with your math professor, you would call it a constant so you can sound smarter. Okay? Today, we're going to combine like terms, which kind of implies that we are going to be combining variable terms with other variable terms, and then we're going to be combining constant terms with other constant terms. But there is something that we need to check, all right? So the process, and this is what I would be testing you on. If you want to combine like terms, there's basically 2 little rules that you got to pass. 2 little check marks. 2 little tool booth people that you're not allowed into the party until you meet these 2 conditions. The first condition, your like terms better have the same variable. And the second condition, and this is the one that people sometimes forget, you better have the same exponent on that variable. Okay? So, for x and for x to the second power are different. Therefore, they cannot be combined. Okay? Because if you look at the 4x and the 4x squared, they both pass the first row, which is same variable. They both got the letter x. However, they differ in their exponent on the variable. Therefore, they're not the same. Does that make sense, everyone? Now, a little way that I kind of think about this, and this is going to sound silly, if you want to combine like terms, what you're really doing is you're bringing family members together. You're going to bring family members together. Now, there are people that you have met in your life that have the same exact first name as you. That's kind of like having the same variable. Okay? Like Crystal, I'm pretty sure you've met at least one other Crystal in your life. Am I right?
Yes.
Okay, now, what differentiates you from the Crystal that you met?
Family.
Say it again, Stevie, so Crystal can hear you.
Last name.
Your last name. Your last name. That's what differentiates you. Think about if you were, in a big area with people and they start calling people's names. If they called out Crystal and there's 4,000 people there, a lot of Crystals are going to raise their hand. However, if they say your specific last name, then you know, oh, I'm the Crystal they're talking about. That's the same thing here. All right? Your variable and the exponent on it is like the last name. So, if you think about it in terms of families, the 3 would be the first name, the x would be the last name. With the second term, the 2 is the first name, the x would be the last name. And with that constant term, that number 1, it has no name. It's lonely. And that's sad, but that's okay. Because later on, we're going to actually combine those things. Now, once you've established that the 3x and the 2x have the same last name, in other words, they have the same variable, and that variable is raised to the same exponent, which in this case is both the number 1, all you got to worry about is what's 3 plus 2. And last time I checked, 3 plus 2 is 5, and the last name would be x. And since nothing can combine with the number 1, which has no name, you know you're done. And that literally is how hard it is or how easy it is to combine like terms. All right? All you're doing is looking for terms that have the same identification markers. That's it. That's it. So let's do some examples here. Notice directions are simplify. 5y plus 7 minus 2y plus 14 plus 10y. Okay? So what I like to do is just read it from left to right. 5 times y plus 7 minus 2 times y plus 14 plus 10 times y. And I'll just start on the left-hand side. I see 5y, and that y is raised to the first power. I will let my eyes go from term to term, and I'll ask myself, do I see any more y to the first power? If I do, I'll mark it in some fashion. So, like, for example, those three terms all have a y to the first power, so I just underline them. Some people will take a highlighter out and highlight them. Some people they'll rewrite it with colored markers or colored pencils. Whatever you got to do to convince yourself that they're the same, that's what you do. Now, I have that +7. Well, that's a constant term, and constant terms are with other constant terms. So notice what I'll do here is I'll put 2 underline marks because I know they're like terms. So now it's just a matter of just adding or subtracting. 5 minus 2 is 3. 3 plus 10 is 13. Last name Y. 7 plus 14 is positive 21. Any questions? How many of us remember doing this?
I do, but why do I feel like we were like your next, if to simplify it, you're supposed to like divide each side by.
Kim fell for my trap.
Huh?
You fell for my trap.
Oh God. Okay.
I know, right? Let me ask you a question. Kim, do not unmute or do not mute yourself. You got to unmute yourself now. It's okay. You are not in trouble, which is a good thing. Let me ask you this question. When you see 5y or 5 times y plus 7 minus 2y, 2 times y plus 14 plus 10 times y, is that an algebraic expression or is that an equation?
That's not what I meant. I meant like the end, the answer, the 13y plus 21. Don't you want to get y by itself?
Okay, so answer my question first, please.
Okay.
Is this an algebraic expression or is it an equation?
Scroll up a little bit. Let me see.
The answer's not on this set of notes. It's in the previous set of notes.
That's what I mean. I meant scroll down because I can't remember. I don't know. I'm just gonna guess.
All right, take a guess.
It's an expression.
It's an expression. Excellent. And expressions always have the directions of simplify. Would you agree?
Yeah.
Now, in order for you to have sides, you got to have an equal sign. Do you agree there? But an equal sign means an equation, correct?
Okay.
Do we have an equation? So you don't have any sides here.
Okay.
So this is just an expression, which means you combine like terms and make it smaller. That's it.
Okay.
You are not dividing things by both sides because there are no both sides.
Okay.
There's just the statement. Does that make sense? All right. In about 15 minutes, we're going to be doing what you said. Okay? Let's do another one here. I want you to do this one. Try that. Very good mistake, Kim, by the way. It's a good mistake. That is what we call a teachable moment. All right, who got an answer?
I did.
All right, go ahead, share your answer, please.
1x to the power of 2 plus 2x plus 7.
Did I write down your answer correctly?
Yes.
Are you sure this is correct?
Well, I'm going to go with it.
Okay. Anybody else get this? Ashley, you got this answer as well?
I got it.
Anybody else?
I did too.
Crystal got it?
Yeah.
Kim, I think you're looking really good because it's correct. Now, before we move on, let's just decipher the information here. 11x squared plus 2x minus 10x squared plus 7. Remember, I like to start, and I'm just going to erase this real fast. I'll start right here, underline it, and then I look for anything else that has x to the second power because I know they belong together. That's right here. Also notice I underlined the sign in front of the 10. That comes along for the ride when you go ahead and you simplify it. So you got to remember that. So 11 minus 10 is 1 x squared. Now, you don't have to write the 1 if you don't want to. I mean, I have a pen in my hand. Do you see a number 1 in front of it? I know it's silly. But if I said I had a pen, you would assume I got at least 1. So if you want to leave it as x squared, that's fine with me. Next, the plus 2x. I don't see anything x to the first power. So I drop it straight down. Same thing with the 7. I just drop it straight down. Kim, excellent job. Everyone else who got it, perfect. All right? Any questions with how to combine like terms? All right. Here comes our favorite part. This is where we actually start taking sentences and then we want to convert them into something that looks mathematically correct. All right? So there are some keywords that we're going to have to remember from the previous chapter, like what does, and I'm not going to review them all. I'm just going to go over a couple. What does more than imply? What operation? Good. Kind of gave you the answer there. What's difference imply? Subtraction. Very good. What about a product?
Multiply.
Good. What about quotient? There you go. So if you need to go back and review them, in your book, I'm in section 2.2. I wish it gave me a page number, but I don't have a physical book. I use the online book. But if you just scroll down, it'll say translate words into algebraic expressions. I'll just show you. Here is a real big table of everything. Okay? So maybe this on the front of a flashcard, this on the back of flashcards. That would help you out tremendously. Okay? Any questions there? All right, so let's do just a couple of these. So the sum of x and 21. Well, you see the word sum. So you know that means you're going to add. And in order for you to add, you got to have at least two things. What are those two things? X plus 21. Okay? Pretty good? Now, we got to be careful because sometimes people say things in a different way, such as this. Seven subtracted from, not form. Subtracted from 4x. And what does that mean?
You're subtracting 7 from 4x.
Okay, so what do I start with?
4x minus 7.
Perfect. Very good, Stevie. Thank you for that. All right, so be careful with that. All right? Now, here's the new one, because I think these two were like review from previous, the previous chapter is just now I threw in a variable. I'm going to see what you can come up with this one. Try that one for me. 3 times the sum of 2 and x.
Would it be like 3 in the parentheses and then 2 plus the x?
Lakendra, let me make sure I'm understanding what you're saying. So you said 3 parenthesis 2 plus x. Is that what you mean?
No, the three would be in the parentheses, right? Because it'll be the times. I don't know.
Okay. Anybody get this or something different? Or better yet, how many of us didn't get anything, which is completely fine?
I got 2x to the third power.
Okay, but wouldn't that think about what you said? 2. What did you say again? 2 to the third power? I mean, if it was 2 to the third power, don't you think you'd see the words 2 to the third power?
Oh, yeah.
Okay.
I got what you had written.
You got what I had written.
Yeah.
All right, so let's think about this before I write anything down. Let's read it one more time. 3 times the sum of 2 and x. So, is there an order here? What do you think? Is this statement kind of telling me to do something first?
Yeah.
Yeah, it's telling me it's telling me I got to do this first. And Kim, since I'm sorry, you're unmuted, I can see it.
I didn't see that.
That's okay. But since this is telling me to do something first, what is it telling me to do first?
Find the sum of 2 and x.
And then it's telling me to do what?
Multiply that by 3.
In the world of mathematics, how can I force you to do something first?
You can.
Yes, I can.
Okay. Right. I don't know.
Parentheses. Remember your order of operations. Parentheses, exponents, multiply, divide, add, and subtract. So if I want you to do something first, I'm just going to put it in parentheses. So then you're forced to do that. And then once you find out what the sum of 2 and x is, all you have to do is multiply it by 3. Does that make sense, everyone? All right, so Lakendra, you were like right there. In fact, to be honest with you, the first thing you said, because correct me if I'm wrong, everybody, but I thought Lakendra said 3 parentheses. See, everyone's nodding their head yes. So you had it right the first time. So good job. In other words, your intuition served you well. And speaking of that, let's talk about that real quick. How many of us have ever taken a test and you had all this math written there, right? And then you went to look over your answers and you did this. You started erasing things and then you did some math, right? And then you got your test back and your professor or teacher circled all the eraser marks and said, you had to correct the first time. Any of us ever been in that situation?
Yes.
What we're trying to
Many times.
what we're trying to tell you here is this. Number 1, go with your gut. You're all very smart people. And you've heard me say this before. We think too fast. We need to slow ourselves down. That being said, go with your gut. Your intuition is going to be better than you second guessing yourself. Okay? So please, just go with your gut. You're all smart. Have faith in yourself. Kim gave us faith this morning when I asked for the one answer and you said, yeah, I'm going to go with it. And you were correct. Just go with it. All right? Let's do another problem like this. All right? How about 2 times the difference of y and x?
It'll be the same as the last. Like it'll be 2 and then parentheses y minus x.
Love it. We all on the same page here. sometimes you need to do math out loud. Don't think about it in your head. Talk out loud when you read the problem. It makes more sense that way. If you're in public, people will look at you like you're crazy. That's okay. All right? People look at me like I'm crazy all the time. 95% of the time when I'm in public, I have headphones in. 95% of the time, there's nothing being played in the headphones. I just don't want to talk to people. Especially if I see somebody I know, I will deliberately go out of my way so I don't have to talk to them. Unless it's somebody I really like. Got it? All right. So let's move on to the next section. We're done with this one. All right. And this last section deals with properties of equality. Okay? Now, when we talk about equality, what we're saying is the left side of an equation and the right side of the equation are equal. All right? So, for example, if I gave you this, how about 6 times x minus 17 equals 16? Okay? What I'm saying is these two sides of the equation are equal. 6 times x minus 17 is equal to 16. Now, sometimes I will say solve for x. Kim, you're familiar with that. Sometimes I may say this question. If I put the word given in front, so given 6 times x minus 17 equals 16 is x equals 5 a solution. So what I'm really asking here for is this. I'm asking you, if I use x equals 5, will I arrive at this conclusion that the left side and the right side are equal to each other? The easiest way to do this, and I'm just going to rewrite the problem real quick. The easiest way for me to do this is I kind of just break it up. And what I mean by that is I'm going to look at the left side first. I'm going to substitute in my value of x. And all I'm going to do is just simplify this down. Order of operations still apply. So, no parentheses, no exponents, multiplication, 6 times 5. Well, that's going to be 30. And 30 minus 17 is 13. Now, the right-hand side was just the number 16. There was nothing for me to do. So now I need to ask myself the question. Does 13 equal 16? And the answer to that is what? No. So we put that line through it. All right? So does 13 equal 16? The answer is no. So x equals 5 is not a solution to 6x minus 17 equals 16 with a little period at the end. All right? So if you think about this, this is very similar to what we did in the previous section, which was, remember the evaluate the expression? Remember me saying that? Here, if you don't remember, let me scroll up. Here, Evaluating expressions. Notice the x plus 7 is an expression. Here, it's basically the same thing. Now remember, an expression equal to an expression is an equation. So all I did was just broke it down. I said, okay, here's my left expression. Here's my right expression. I want to know if these two things are equal. So how about we do an example where we do arrive at a good conclusion? So determine whether y equals 2 is a solution to 6y minus 4 equals 5y minus 2. All right. So I already know what they're asking me to substitute in. That's right here. Y equals 2. So what I'm going to do is just break this down. We got the left. We got the right. I'm going to substitute in my value of y. So for the left, it's going to be 6 times 2 minus 4. And for the right, it'll be 5 times 2 minus 2. Just do one side at a time. 6 times 2 is 12. Minus 4. And 12 minus 4 is 8. For the right-hand side, 5 times 2 is 10. 10 minus 2 is 8. So, 8 equals 8. You put a big smiley face. And then if you want to, you can write a statement. And I like writing sentences. Yes, y equals 2 is a solution to 6y minus 4 equals 5y minus 2. Are there any questions there? All right. Now here comes the fun part of the lecture. I'm going to scroll up just a little bit because I want to show you something. In this example, I gave you a value of x. I said, try it out. Tell me if it works. In the second example, I gave you a value of y. And I said, try it out, see if it works. What if I didn't give you a value? If I didn't give you a value for x, what do you think the directions would be? That's why I left a space there, because I'm going to write directions in between there. What do you think the directions would be here?
To solve for x.
Excellent. The direction would be solve for x. Now, I think, and I'm going to throw this out there, but I think we could kind of look at this problem and guess what the answer is. X minus 2 equals 8. What does x have to be?
By itself.
Well, yeah, but I'm asking for the value of x. What do you think it is?
Negative.
Well, I don't know about that.
10.
Yeah, got to be 10. If you think about it, 10 minus 2 equals 8. I mean, you could guess that. What about this example? One plus x equals 5. I think we can guess what x has to be. What do you think x equals?
4.
4. Good. Even this example. 2 equals x minus 1. What do you think x has to be? Yeah, 3. All right, and over here it was equal to 10. Now, this is all fine and dandy. This is nice. The problems are small. We can kind of just use a little bit of deductive logic here and figure out what each one of these equals. The question becomes, when the problems get difficult, do you think guessing is an effective method on solving something? Absolutely not. So you need properties. You need rules. All right, now, we're going to be building basically a set of 6 rules to solve an equation. But we're going to do it very slowly, all right? So the first one I want to talk to you about is this. It's called the addition property of equality. Okay? And the funny thing is you already know this. You already know this property. I'm going to say this phrase and just nod your head or use the reaction in Zoom with your hand up or a wave or something like that. Entertain me a little bit if you've heard this before. You ready? If you add something to one side of the equation, you must add it to the other side. That is called the addition property of equality. You already know this. Now, how many of you knew that it actually had a name? Kim's like, nah. And I agree. I agree because it's one of those things that a math teacher will go over once and then they never say it again because they think it's super easy. And they think that everybody just gets math as fast as they did. That's not the case. So what we're going to do is we're going to slow down. The addition property equality, here's what it says. It says if you start off with 2 different quantities, one on the left, one on the right, but you have an equal sign in between. It says that if you add something to the left-hand side, in this case I'm adding this plus c, then in order for me to maintain equality, I have to add the same exact thing to the other side. Does that make sense, everybody? That's all it says. And as I said earlier, you already knew this. Whatever you add to one side of the equation, you must add to the other side. Okay? So you already heard this before. So if I have a very simple problem here, boy, this problem looks familiar. But if I have x minus 2 equals 8, and we already know the answer. The answer I'm going to write all the way down here. We know it's 10. We guessed that. But now let me prove it to you. Let me demonstrate that it equals 10. My goal, anytime I solve equations, is to always isolate the variable. Now, you got an equal sign, which means you have 2 sides now. You have a left side and you have a right side. Okay? If my goal is to isolate the variable, my eyes instantly fixate on the left-hand side here. Okay? Because that's where the variable is. Now, I want to isolate the variable, so that minus 2 I need to get rid of. And what I mean by get rid of, what I mean is I need this negative 2 to appear over there. Okay? But in order for me to take that negative 2, which is on the left, and make it appear on the right, which is the opposite of left, I need to do the opposite of negative 2. In other words, What I need to do is add something to both sides of the equation because I want it to disappear on the left-hand side and reappear on the right-hand side. And in order for me to do that, I'm going to add 2 to both sides of my equation. How many of us remember doing something like this? Okay. So, by adding 2 to both sides of my equation, -2 plus 2, that's 0. So now it's like x, it's isolated, and 8 plus 2 is 10. So now I have a very systematic way of doing problems. All right? And that way that I do that is our very first property. And it's called the addition property of equality. Are there any questions about this? I had a professor when I was in my sophomore year, Dr. Williams. He was great. Fantastic guy. Excuse me. And the way that he taught this was, he would say, you're dancing around the room. And I kind of thought about it. I was like, what does he mean by dancing? If you notice, I took this -2 and I moved it to the opposite side of the dance room by moving it. So sometimes you'll hear me refer to, okay, let's dance with the equation. And when I say that, that means we're moving things around from left to right. Okay? Other times we are combining like terms, which means simplify. All right, so let's make sure we don't get those two things confused. Expressions, simplify. Equations, solve. Okay? Are there any questions? All right, let's do a couple examples. We'll call it a day. The last one is a little tricky. So go ahead, take a minute, do those 3 problems. We'll come back. We'll go over them. Okay, are we ready? Or do we need another minute? I'll give you a minute. All right, so let's go over these 3. We'll call it a day. Y minus 1 equals 3. Our goal is to isolate the variable. So I look on the left-hand side and I read it, y minus 1. Now I need that -1, that -1, to go to the opposite side. So I'm going to do the opposite operation. I add 1 to both sides. I get y equals 4. Any questions there? Good. Middle example. 27 equals a minus 16. Remember, my goal is to isolate that variable. So I look on the right-hand side because that's where it's contained. And I read it a minus 16. So that minus 16 needs to go from the right to the left. So it's the opposite side. Therefore, I will do the opposite operation. So on the right-hand side, I get an A. But on the left-hand side, 7 plus 6 is 13. Carry the 1. 2 and 1 is 3 plus 1 more is 4. So you get 43 equals A. Or another way you could say that is A equals 43. All right, now this last one is different from all the other problems we did. Because all the other ones, I had to add something to both sides. Well, in this case, I need to do the opposite of add, which is subtract. So I'm going to subtract 5 from both sides to give me x equals 5. We call that the subtraction property of equality, which is the same thing. If you have two things different that are equal to each other, you are allowed to subtract the same thing from both sides. You are allowed to do that. You got to make sure it's the same thing.